Hey guys, Tim from MVP Machine. Finishing up on a project that I'm doing for a friend of mine. It's basically an electric trike, and it'll be used for factory transportation. His company wanted something that they can use inside. They have a very large shop, and to go from one side of the shop to back to the warehouse, and to transfer prints and parts around. And they basically wanted the back basket to be left open, so that was out of out of consideration for a battery. And then on these trikes, there's really no good places to put a fairly good size 34-pound battery. This battery is made to go under a normal bike, basically in like the area like that, which it would not fit in this bike, but or trike, I should say. But what we've done is created this. Eventually, this will be covered with like a saddlebag assembly, so you won't really see the battery at all. It'll be like a zip-up assembly that goes around it. But this is almost finished. There's still one cover left to be made, or cover assembly, to cover the wiring. And one of the keys for this project was to not really have any wires visible. And basically all you have is a hub motor, 1100 watt, or I'm sorry, 1000 watt hub motor. You've got one wire that goes up to the battery, or actually the motor controller, which is here, and then one cable from the throttle that goes to the motor controller, and that's the only wiring that is visible. Everything else is contained inside the battery case and goes to the motor controller. This is my old English Bulldog puppy Butters. He's helping me at the shop today. So the purpose of this video is I want to show you how to make and bend thin metal assemblies like this. And it actually makes pretty strong structure and almost indestructible, but yet very light. And you can, this is an 1/8 inch thick aluminum, but you can also do this with stainless or even mild steel. What I've done is created some tabs here that are threaded, and basically it's like a 10-piece assembly with the two sides, and basically a series of plates all the way around. And then we have UHMW plastic that traps the battery inside, and there's some foam under the UHMW. UHMW is here. There's another support here. There's one here, and then one in the back. And it holds it very, very sturdily in there and gives it some cushion. This assembly is very strong. You can pick up the bike with it and it doesn't show any signs of weakness. It's held to the handlebars with the switching assembly, one on each side. And then at the bottom there's a tab that bolts to where the fender attaches to the bike. So I'm going to show you how I created this case, and we're basically going to be making this bottom cover assembly, and we'll go from there. If you hear snoring in this video, it's coming from Butters. He's in his little hideout under the shop table. Okay, we're over at the computer now. This is a CAD file of that side case for the battery, and basically what you're looking at, the green represents the shape of the part. The light blue inside represents the battery for visual reference inside the case. And then I wanted to zoom in on one of these tabs and show you what's going on with these. We basically have a 1 inch across by 5/8 tall tab with an 1/8 inch radius on each side of it, and then we have a scribe line drawn from the midpoint of each radius, and that scribe line represents a cutter path for an 1/8 inch ball nose end mill. And we're basically going to be sending that end mill right on top of that line 30 thousandths of an inch down, and that will create a bending point and also a visual reference for us to accurately bend these tabs. And what we're going to do now is just going to show you the 3-piece assembly cover on CAD that we're going to be making today, and then we'll actually make that assembly and show you how to bend it. Okay, what we've got here is the side plate for the 3-piece assembly that's going to become that wiring cover. And there's going to be 2 side plates that look like this, but they're not identical. They're a right and a left, or shown in an opposite, just because this scribe line basically indicates the bend direction. So wherever you scribe that 1/8 inch ball nose scribe line, that's the direction that you bend towards. So they have to be a right and a left. And then the 3rd piece of this assembly is a plate with 4 holes. It's basically, once the tabs at the bottom are bent over, is going to hold together the 2 sides, and that's going to make up our 3-piece assembly. So we're going to get some aluminum set up on the mill, and we'll have a sacrificial plate under it, basically so that we don't cut into the table, and we'll show you how we cut this out and bend it. As I'm setting up the machine, I thought I'd take a second to show you a product that we make that you might be interested in. We make these rounded end T-slot nuts. It's basically a hardened T-slot nut. Right now, the only size that we have is 11/16, or the equivalent of 17.5 millimeters. And that's the key dimension. We have 2 different hole sizes available, 5/8 and 1/2 inch. This is a 5/8. And it does fit in a Fidel machine. I would assume these would be standard on most Fidel machines. I think some Haas machines have the same size T-slots. Eventually we're probably going to make them for Bridgeport sizes as well. They're basically a 38 Rockwell hardness, and a little bit nicer, a lot nicer than most T-slot nuts that you have look like throwaways. They've got saw cut ends, and they're real soft material. And these are T-slot nuts that you'll have but for life. So there'll be a link in the description below to our eBay store, and we're going to get this last clamp set up and get cutting on these plates. Okay, we're ready to roll here. I'm going to show you with a Sharpie the cut order, because it's kind of important. So here we go. First, we're doing basically the tab. That would be the line that represents the 1/8 inch ball nose end mill. Then we do our holes. And then we're going to cut out the outside. And obviously you have to save the outside for last, because there's going to be very little, if anything, holding this part in place after that gets cut out. I like to do this also just to make sure there isn't going to be any collision with clamps. It's the first time I've set this up on the machine. So now we're going to get going. We'll send the 1/8 inch ball nose in first. Okay, we're going to start off with the 1/8 inch ball nose, and let me see if I can zoom out a little bit. And you may not be able to see a whole lot with the coolant, because I have to use flood coolant. I'm using a carbide 1/8 inch. I'm running it at 7,200 RPMs and 35 inches a minute. bottom two holes, which are .213 in diameter for the quarter 28 cap. And I will not tap it on the machine because I don't have enough through, over through holes. I'll just hand tap them after. The top hole is a .260 clearance hole for the quarter 28 that holds the assembly to the bottom of the battery case. Now this is the quarter-inch carbide end mill. This is going to be running at 6,400 RPMs and 85 inches a minute, and we're ramping down 10 thousandths per pass. I'm going to duck back a little bit just in case it gets a little swirly. I could have been a little more aggressive with that cut, but sounded like we popped through at the end there. And there's our plate. Small amount of deburring to do, so I'm going to do that. I'm going to deburr this part. I'm going to cut the other two out, and then we'll show you how we bend it. Okay, we've got our three parts done. There's one set up in the vise, and here's the other two parts. We've got the other side here, and we've got our cover plate for the bottom here. And the one set up in the vise, I'm going to show you how I bend it. I'm going to zoom in on how I have that lined up. Basically, we have the scribe line that goes 30 thousandths of an inch deep, and that faces us. And we want to line that up the very bottom of the scribe line with the top of the jaw. And I used them level just to make sure I was halfway close. And then what you do is you take a 246 block and put it behind the part on your back jaw, right up against the part. And then with two hands, just pull it towards you. And it takes a little bit of effort. Until you have what you feel is 90 degrees. So you can probably go a little further. And that looks pretty good. And that's what you wind up with. See if I can zoom in here a little bit better. On the inside you can barely even see that there's a seam there. Now I've got to do it to the other side, and I'm going to have to put a block in there so I won't have the clearance. So let me pause this and I'll show you the other side. Okay, I actually had to set it up on two blocks, one behind it and one in front of it, and hopefully our block will go right between the center here. And same thing, 2-4-6 block behind it, and just pull straight towards you with even pressure. And that one bends a little easier because it's just one tab. A little bit more. And there's our bracket. Now we'll make the other one, and this assembly basically will go together just like that. These holes are threaded. And now here's our assembly fastened together, and pretty much that's what it's going to look like assembled. Has to go on the trike in 3 pieces though, because these inner tabs have to go on first because you wouldn't have access to the screws for those. So we're going to get it on the bike. Okay, I've got the wiring cover assembly installed on the trike. Worked out pretty good. I had to do some modification to the bottom cover plate to make some clearance for the fender. It was a little bit too tight there. And all in all, I probably had total machine time in it, maybe 15 minutes on all 3 parts, and then some deburring, and I guess with design and everything about 2.5 hours. And just a video to show you guys. I've used this method to make many things that would be kind of too complex to make any other way. If you were to try and do this on a press brake and bend this, you really wouldn't have access to mount the battery in there. So this is kind of a neat way to make assemblies that otherwise are very difficult to make. And it looks a little funky on the bike, but once the saddlebag, the zippered assembly is on there, it'll cover it up. And that's going to be about a month before that's ready. And the customer wants to take it and start using it first. So a little tour of the bike. It's basically got the power button for the battery is here. There's the charge port for the battery. On the other side of the battery, you've got a charge indicator there and a USB port that's got a boot on it. And then up here in where I have these 3 holes that don't have any fasteners in it, that's going to be a magnet that goes under the zip-on cover, and that will be for a headlight. In case they want to put on a headlight, they can just slap it on the magnet. I'll have that. I'll make up that assembly myself. We have a quick release phone mount on here. You could use it for your camera on your phone, or just download a GPS speedometer. Your phone just slides in it, and there's a clip on the side that holds it securely in there. Over here we've got the Schwinn bike bell. That's your horn to get people out of the way. Got the power button and another charge indicator, and then our twist throttle is right here. You twist it and it goes. I just had it out for a test drive, and it's kind of a strange feeling. I have an electric car, and well, a semi-electric car, Chevy Volt, but this is a little bit different. It's totally silent, and you're just out in the open. You kind of feel like you're flying. So I think that's about it. I'm going to take it out to the parking lot, and I'll show you guys what it does. Okay, here we go. Before we go for our ride, please remember to like, subscribe, and hit the notification bell if you like the video. And also be sure to comment if you have any comments. Here we go, by the end of the parking lot. We're probably going to hit about 25 miles an hour. Thanks for watching our video.